Alright, so what we're going to talk about in this video is statements and truth tables. Statements and truth tables. And what a statement is basically the mathematical way to say something. Something that isn't an opinion, but something that is a statement. Something like, let's say, P represents the boy does his homework. And what you can do is a statement is something that can be either true or false. And if it's true, then the statement is true. If it's false, then its negation is true. And the negation is not P. And we would denote it by putting this little elbow in front of it. It's kind of like a negative sign, but and that restates the statement in the according opposite manner. So the boy does not do his homework. And everything else is the same. So statements can be compared using operators, and there are 4 operators. There's the and symbol, the or symbol, the implication symbol, and the if and only if symbol. So we'll talk about what these means, because what we're going to do is compare P and Q. Q is another statement. Q could be something along the lines of, then his mom gives him ice cream. And obviously the negation of that would be she does not give him ice cream. So not Q is his mom does not give him ice cream. So put that in parentheses. So P and Q, that is a statement that we can evaluate using a truth table. And what I mean is, actually, I want to start with the tricky one so the simple ones make more sense. So P implies Q, because that's what we're really using in this example, is what does the truth table look like for this statement? And the way you set it up is you put your P and your Q, and P can either be true or false. And for each true, Q can either be true or Q can be false. And same thing for each false, Q can either be true or false. And it's important to keep these things neat and orderly. So, I mean, really you're supposed to have another true here, another false here, and these things don't really exist. But anyways, so P implies Q's. What we're looking for in this statement is to prove if the person who is stating the statement is a liar. So mom gives the boy a condition. She says, do your homework. P, your P must be true. Must be true. And then if that happens, then I will reward. So if the boy does his homework and the mom gives him the reward, then the mom is not a liar. It's true. But if the boy does his homework and the mom does not give him the reward, then the mom is a liar. So that's false. Now, if the boy does not do his homework, then you can't move from the condition to the reward because the condition was not met. So it doesn't even matter. The mom could give the boy ice cream even if he didn't do his homework, that would be a bad idea because you don't want to reward negative behavior. But um, if the boy doesn't do his homework, then he can't prove the mom was a liar. So these will both be true because the mom is honest. Now, P and Q. What does P and Q look like? P and Q. Is that the same blue? All right, so P and Q. In order for this to be true, both P and Q must be true. So true and true, that satisfies the equation. The rest of these are not all both true. True and false, that's false. False and true, that's false. False and false, well, that's obviously false. Now, P or Q is a lot easier. And we'll get to that one later. But P or Q, only one of them has to be true for the statement to be true. So true or true, that's true. True or false, that's true. False or true, that's true. Now false or false is the only instance where this is true, or this is false. And now P, if and only if, is the same thing as saying P implies Q. I want to write this out, so P implies Q, and put these in parentheses, and there's no A, there's no crossbar there. Can you guess? Q implies P. If and only if means it goes both ways. So the only thing that would change is this one right here. The the mother would not give the boy ice cream if he does not do his homework. You will get ice cream if and only if you do your homework. If you do not do your homework, then you don't get ice cream. So what does that look like? Well, we know what P implied Q looks like. That's true, false, true, true. Let me just write that. True, false, true, true. And Q implies P is the same, but in the opposite direction. So if you wanted to just check it, Q, the boy, let's just flip these. Let's say Q's are now P's and P's are Q. Boy does his homework, mom gives him ice cream. That's true. Boy does not do his homework, mom gives him ice cream. Okay, mom is not a liar, even though she spoils him. Boy does his homework, mom does not give him ice cream. This is the one I said would be different. Boy does not do his homework, or boy does his homework, mom does not give him ice cream. That's false. And false, false. Boy doesn't do his homework, but because he didn't do his homework, you can't call mom a liar. Now, we're going to evaluate the and between these two statements. True and true is true. False and true is false. True and false is false. True and true is true. So for P implies Q, true, false, false, true. That is our evaluation. True, false, false, true. And that's based off of these cases. This is case 1, 2, 3, 4. So, and this is how it evaluates out. So that's how you use a truth table. So now, using this knowledge, we're going to evaluate some tricky problems. Tricky if you haven't been exposed to it, but they're fairly straight up, actually. Let me just finish cleaning this up a little bit. Okay. So, let's see here. What kind of questions do I have? Actually, I'll just save that for the next video. I'll see you there.